Imagine this happened under perfect laboratory conditions. No magnets, no wires, no airflow, no hidden machinery. A human being looks at an object, and the object moves. At that moment, only 3 explanations would remain. The experiment was fraudulent. The researchers missed an ordinary physical mechanism. Or humanity had just discovered an interaction with matter that modern physics does not yet understand. Telekinesis is usually treated as fantasy. But instead of asking whether it is real, let us ask a more dangerous question. What would have to be true for telekinesis to work? And could it operate not like an energy beam, but like an invisible hand? Telekinesis, traditionally called psychokinesis, is the claimed ability to influence physical matter through mental activity without ordinary physical contact. It can be divided into 2 categories. Macro-psychokinesis means visible effects, moving a glass, bending a spoon, or levitating an object. Micro-psychokinesis means producing tiny statistical changes in systems such as random number generators. These are radically different claims. Moving a visible object requires measurable force, energy, and momentum. Changing the statistical output of a quantum device might require only a minute influence, but it would still demand a mechanism. At present, no controlled experiment has produced a reliably repeatable demonstration of macroscopic telekinesis. That does not mathematically prove it is impossible. It means the phenomenon has not crossed science's most important threshold, independent replication. Researchers have tested whether human intention can influence electronic and quantum random number generators. Some early studies reported very small deviations from chance, but the effects were inconsistent, heterogeneous, and vulnerable to methodological problems. In one large online experiment involving more than 12,000 participants, researchers tested whether intention could influence a quantum random number generator. The Bayesian analysis produced evidence supporting the null hypothesis. No micro-psychokinetic effect was detected. Earlier high-powered replication attempts had also failed to reproduce prominent positive findings. That distinction matters. A strange result is not yet a discovery. Researchers must eliminate equipment defects, unnoticed correlations, selective analysis, sensory leakage, statistical errors, and deliberate deception. And then another laboratory must reproduce the result. Without that, an anomaly remains an anomaly. This is where the story becomes irresistible to conspiracy culture. Governments really did investigate alleged psychic phenomena. The United States funded programs associated with remote viewing, anomalous cognition, and psychokinesis during the Cold War. Declassified CIA archives contain reports discussing metal bending, random systems, and purported psychoenergetic effects. But the existence of a classified document is not evidence that its claims were confirmed. Intelligence agencies investigate uncertain possibilities precisely because they do not know whether they are real, and because they fear an adversary may be investigating them, too. A 1995 evaluation of the Stargate remote viewing program concluded that the information produced was vague, inconsistent, and not useful for actionable intelligence. Remote viewing is not telekinesis, but the evaluation illustrates the gap between investigating a paranormal claim and validating it. The truthful conclusion is therefore less exciting than either extreme. The government did investigate psychic claims. That investigation did not establish reliable operational psychic powers. The human brain is electrochemical. Every thought involves moving ions, changing voltages, and synchronized activity among populations of neurons. Those currents generate magnetic fields, which can be detected using magnetoencephalography, or MEG. So could thoughts simply produce a magnetic force? The scale says no. Magnetic fields measured outside the brain are extraordinarily weak, typically around the femtotesla range, approximately 10 to the power of -15 Tesla. They are so faint that MEG machines require extremely sensitive detectors and carefully controlled environments. Earth's magnetic field is roughly 10 billion times stronger. The brain's known electromagnetic field cannot lift a spoon, move a glass, or pull a chair across a room. Something else would be required. Popular fiction often portrays telekinesis as a beam. The mind sends energy toward an object and pushes it, but a beam is a poor model for what fictional telekinesis appears to do. A hand does not merely push. It grips, it stabilizes, it rotates. It applies different forces to different surfaces at the same time. For telekinesis to behave like an invisible hand, it would need to create a structured, three-dimensional field around the target. The field would act less like a bullet and more like an invisible glove. This idea is not entirely alien to physics. Fields can store energy, carry momentum, and exert pressure. Light can push matter through radiation pressure. Highly focused light can trap and manipulate microscopic particles in devices called optical tweezers. Magnetic fields can levitate certain materials. Gravity shapes the trajectories of planets without physical contact. None of these mechanisms explains telekinesis, but they establish an important principle. An invisible field can act mechanically on matter. One possible model would use a field gradient. Imagine that an unknown field changes the potential energy of matter at different locations. The target object naturally accelerates toward the region where its energy is lower, like a ball rolling into a valley. Move the valley, and the object follows. To lift an object, the field would create an upward gradient strong enough to overcome gravity. To hold it still, the field would create a stable three-dimensional minimum. To rotate it, the field would apply different forces across different parts of the object. In mathematical terms, the invisible hand would not be a single force vector. It would be a controllable stress field. This could explain the apparent grip of fictional telekinesis far better than an undirected blast of mental energy. But it creates a new problem. How does the field know which object to grip? A usable telekinetic force would need extraordinary selectivity. If it coupled to mass in the same way as gravity, it would affect everything nearby. If it coupled to electric charge, it would interact with air, walls, electronics, and the person generating it. Yet fictional telekinesis can lift one key from a table while leaving every other key untouched. The unknown interaction would therefore need an addressing system. Perhaps it couples differently to particular atomic compositions. Perhaps the user shapes the field with extreme spatial precision. Perhaps the target must first enter resonance with the field. Or perhaps an information-rich control process continuously maps the object's surface and adjusts thousands of force vectors in real time. That would make telekinesis less like firing a weapon and more like operating a robotic limb. The brain already performs this kind of calculation for the body. It controls many muscles simultaneously, predicts motion, corrects errors, and uses touch and vision as feedback. A telekinetic system would require a comparable external feedback loop. Without feedback, the invisible hand would be blind. No mechanism can escape energy conservation. Lifting a 1 kilogram object by 1 meter requires approximately 10 joules of mechanical energy. Holding it stationary requires force, although an ideal static field would not necessarily consume mechanical work once established. Accelerating it requires both energy and momentum. If the brain supplied all of that energy metabolically, powerful telekinesis would quickly become biologically expensive. But perhaps the brain would not be the engine. It could be the control system. A small electrical signal can open a valve controlling a massive hydraulic machine. A transistor can use a weak input to control a much larger energy flow. In the same way, a hypothetical biological structure might modulate energy stored in an ambient field. The brain would steer the hand. The surrounding field would provide its strength. That solves the brain power problem only by creating a larger mystery. What is this ambient field, and why has every precision instrument apparently missed it? It is tempting to call the unknown source dark energy. But cosmological dark energy is not currently known to behave like a local mechanical force. It appears through the accelerated expansion of the universe and is weak on the scale of people, laboratories, and planets. Leading possibilities include a cosmological constant, a changing field sometimes called quintessence, or a limitation in our theory of gravity. A telekinetic field would therefore probably not be dark energy itself. A better speculative candidate would be a new dark sector interaction, a field or particle that interacts weakly under normal conditions, but can somehow be locally activated or amplified. Physicists already search for hypothetical fifth forces mediated by new scalar or vector particles. Experiments using torsion balances, atomic sensors, spectroscopy, astronomical observations, and equivalence principle tests have placed strong limits on broad classes of such interactions. This does not eliminate every imaginable field, but it gives the field a very narrow escape route. It must be strong when deliberately activated, almost invisible at all other times, and selectively coupled so ordinary matter does not continuously betray its presence. Possible in a story? Yes. Natural according to current physics? Not remotely. There is another requirement science fiction often ignores. When the invisible hand moves an object, momentum must go somewhere. If a person telekinetically throws a heavy object forward, something must receive equal momentum in the opposite direction. Perhaps the user feels recoil. Perhaps the field transfers momentum into the earth. Perhaps waves carry it away, or perhaps the field's source experiences a reaction force too small or distributed to notice. But if no reaction exists anywhere, momentum conservation has been violated. A serious telekinetic theory must identify both sides of the interaction. What pushes the object? And what does the object push back against? Even if this field existed, a biological organism would need machinery capable of controlling it. That machinery might require a receptor that senses the unknown field, a biological transducer that converts neural activity into field modulation, large populations of synchronized cells, a method for locating targets in three-dimensional space, and a feedback channel that reports force, texture, movement, and resistance back to the brain. No such organ, cell type, or molecular pathway has been identified in humans. But a technological version already exists. Brain-computer interfaces can decode neural activity and use it to control robotic arms. Bidirectional systems can also return artificial touch information to the brain, improving a user's ability to grasp and manipulate objects. That is not paranormal telekinesis. There are sensors, computers, motors, and power supplies between the thought and the object. But from the user's perspective, the result is strikingly similar. Intention becomes external movement. Science may create the experience of telekinesis before it discovers or disproves the supernatural version. Suppose someone genuinely claimed they could move an object without contact. What would a decisive experiment look like? The target would sit inside a sealed vacuum chamber, eliminating airflow and acoustic pressure. It would rest on an ultra-sensitive torsion balance or force sensor. The chamber would be isolated from vibration and monitored by multiple independent cameras. Magnetic fields, electric fields, temperature, pressure, radiation, and mechanical movement would be recorded continuously. The participant would be searched for concealed devices and placed far enough away to prevent physical interference. The procedure would be double-blind. Target periods and control periods would be randomly selected by a computer. The analysis would be pre-registered before data collection. Magicians and fraud specialists would inspect the setup. Most importantly, the entire protocol would be repeated by independent laboratories. If motion occurred, researchers would then ask, does the force weaken with distance? Does it depend on the object's mass or chemical composition? Can it pass through shielding? Does the participant experience recoil? Is heat generated? Do nearby clocks, atoms, magnets, or electrical systems respond? A genuine phenomenon would leave a pattern, and that pattern would begin to reveal the force's properties. The objective should not be to prove believers right or skeptics right. It should be to make deception, bias, and ambiguity progressively harder until only reality remains. At present, the evidence does not show that humans can move objects through thought alone. Known brain fields are too weak. Controlled psychokinesis experiments have not produced a reliable, independently replicated effect. And no accepted biological or physical mechanism can create the invisible hand. But asking how telekinesis would have to work exposes something valuable. It turns magic into engineering requirements. The hand must couple to matter. It must form a stable spatial structure. It must target one object without disturbing everything else. It must carry energy and momentum. It must provide sensory feedback, and it must leave measurable evidence. Perhaps no such force exists. Perhaps telekinesis will remain permanently inside mythology and science fiction. Or perhaps, hidden somewhere beyond the standard model, nature contains an interaction that we have not learned how to touch. Until the evidence arrives, the scientifically honest position is neither belief nor ridicule. It is curiosity, with instruments switched on. So, if an invisible hand really existed, what experiment would you use to catch it?